All right, calculus students, Ms. Deere back on the mic here. We are talking about series. And we have talked about two kinds of series where we can actually find the sum. Is it geometric or is it telescoping? Remember that a geometric series, the sum from n equals 0 to infinity of a times r to the n. If the absolute value of r is less than 1, so between -1 and 1, it converges to a over 1 minus r. If r is 1, you can see that you would have a plus a plus a plus a plus a, which would diverge. If r was -1, you'd have plus a minus a plus a minus a, which would also diverge. Then our next test is, is our series past the nth term test? Remember, this can only prove divergence. If the limit, as n approaches infinity, of a of n is not 0, then the series diverges. If the limit of the terms is 0, then we have to try something else. Our third term, or our third test, is the sum of 1 over n to some power. If p is greater than 1, this converges. If p is between 0 and 1, it diverges. If p is 1, this is the sum of 1 over n. The sum of 1 over n is harmonic series. And we know when we see the harmonic series, it diverges. All right. Then our next test is, what if we have something that's almost a p-series or almost a geometric series, but not quite? This is when we use direct comparison. And if I have two series, a n and b n, if they're both positive, if the big one converges, the smaller one also converges. If the smaller one diverges, the bigger one also diverges. And then if we can't quite use direct comparison, then we can use limit comparison, which says that if they are both positive and the limit, as n approaches infinity, of the ratio is L, where L is finite and obviously positive since these are both positive, then AN and BN either both converge or both diverge. And then we have plan Z down here, which is the integral test. So let's go through a few examples of each of these. Our first example here is, let's say I have the sum. Now remember, anything goes here, from n equals 1 to infinity, of 3 over 2 plus 5 to the n. So we ask ourselves, is it geometric? Is it telescoping? No. So we can't find the sum of the series. Do the terms go to 0? Yes. So it does not immediately diverge. Is it a p-series? No. Is it almost a geometric series? Let's compare this to 3 over 5 to the n. Now this is a geometric series and it converges because a is 1/5. This is 3 times 1/5 to the n. So because I have more in my numerator here, 3 over 2 plus 5 to the n is always smaller than 3 over 5 to the n. So by direct comparison, they both converge. Because my series is smaller than a series that converges, they're both positive, so they both do the same thing. So what does this series do? Well, it's not geometric and it's not telescoping. It fails the nth term test. The limit as n approaches infinity of n plus 1 over n plus 5 is 1. The limit of the terms of the sequence is not approaching 0, so it fails the nth term test. It diverges. How about the sum from n equals 1 to infinity of 3 over 2 to the n? This is a geometric series. R is 3 halves. 3 halves is bigger than 1, so it diverges. Let's look at the sum from n equals 1 to infinity of, let's do 10 over n. Well, we look at this and it looks a lot like the harmonic series. We know that 10 over n is always bigger than 1 over n. And what does this series do? We know this diverges because it's harmonic. So if 10 over n is bigger than 1 over n, this diverges by direct comparison. Let's look at a couple more. Let's look at the sum from n equals 1 to infinity of, let's do 2 over n cubed plus 4n. Well, if we compare it to 1 over n cubed, this is not always smaller than this because of the 2 in the top. So we're going to have to use limit comparison. So if we take the limit as n approaches infinity of this series over this series, so we get 2 over n cubed plus 4n. Dividing by this is the same as multiplying by the reciprocal. Now, in our minds, we can L'Hopital this 3 times, or we can see that because the degrees are the same, the limit's going to be the ratio of the leading coefficients. So my limit is 2. This limit is a finite positive number, so both of these series are going to do the same thing. So we picked a p series that converges, so this one also converges by limit comparison. Let's do the sum from n equals 1 to infinity of, let's do 2 over negative 3 to the n. So if we just write this as 1 to infinity of 2 times negative 1/3 to the n, you can see it's geometric, and r is negative 1/3, which is less than 1, or sorry, between negative 1 and 1. Oh. The problem is if we're going to find the sum of this series, it doesn't start at 0. So let's figure out if n equals 1, the first term of this series is 2 times negative 1/3. So a is 2 times negative 1/3. My ratio, remember when I rewrite a geometric series, does not change. So this series is the same as the sum from n equals 0 to infinity of negative 2/3 times negative 1/3 to the n. A is negative 2/3. R is still negative 1/3. And because I'm going from 0 to infinity, we know this converges to A over 1 minus R. So 1 plus 1/3 is 4/3, so negative 2/3 divided by 4/3, so times 3/4. This converges to negative 1 over 2.